Hi, welcome back to Crispy Basics. Today we're going to talk about current, and more specifically, how current can be thought of as water flowing down a river. This analogy is useful because our river can become narrow and resist the flow of water, and since a river is flowing downhill, the water has some energy that can be used for some useful work, like spinning a water wheel. Let's assume at the top there's 100 gallons of water per second flowing in. If no water is splashing out and that water only has one path, then at the bottom of the river there should be 100 gallons of water per second flowing out. This brings us to our first important concept about current. When there is only one path for current to go, current is constant throughout that path, no matter what components are in between. For example, in this simple circuit, if 1 amp of current is flowing through this resistor, then there must be 1 amp of current flowing through this motor. Much like in our river example, if there's 100 gallons per second flowing through this narrow portion of the river, then there must be 100 gallons per second flowing through this water wheel. But what determines how much water is flowing through a river? Further up our river is a reservoir and dam capable of supplying 1,000 gallons of water per second. If it can supply 1,000 gallons per second, why is only a tenth of that flowing through the river? This brings us to our second important concept about current. Just because a reservoir can supply 1,000 gallons per second, it does not mean that it will supply that. It is entirely dependent on what is downstream resisting the flow of water, and how much energy the moving water has by flowing downhill. To put it in electrical terms, the flow of current is dependent on voltage and resistance. If we increase the voltage, decrease the resistance, or do both, then current will increase. If instead we decrease the voltage, increase the resistance, or do both, current will decrease. This relationship is captured in an elegant equation called Ohm's law. In a future video, we'll take a closer look at Ohm's law and see if our river analogy still holds water. Thanks for watching. Leave a like if this video was helpful, and comment down below what electronic topic I should cover next.